Thanks for tuning in tonight and watching this video on our new lesson, Average Value of a Function. It's a pretty simple lesson, and actually, in this first section, I am just going to give you the formula straight up and show you how to use it. So just by learning this little section, you're going to know how to do the homework. What I'll do after, in the next section, and on the next page, is for my why people. I'm going to show you where the formula comes from and why it is what it is. So let's just start up here with the definition. It says, the average value of a function. If f is integrable, that just means able to be integrated. You can take the antiderivative of the function. So if f is integrable on the closed interval a to b, then its average or mean value on that closed interval a to b is, and here's the formula. Average value, so anytime you're finding an average value, guys, you want to notate it like this. You don't write the whole word average out, you just write AV. So the average value of the function f equals 1 over b minus a times the definite integral from a to b of f of x dx. So you're used to this part right here. This part I'm highlighting in pink is just the fundamental theorem of calculus. Then all you do is take the result of that and multiply by 1 over b minus a. Now, what does that find? Well, this is just the average of all the y values on an interval a to b. So you're used to finding averages of data sets, like when you're back in middle school or elementary school, you found the mean, median, and mode. Like you're used to taking a set of data, finding the average. But I don't know that you've ever found the average of a function, and that is just the average of all the y values. So here's how you run the homework. So example 1 says, find the average value of f of x equals x squared from 1 to 4. So tonight, when you do the assignment, you're literally just going to do this. Using this formula, you're going to set it up. Average value of f equals. Okay, so we know that the 1 is the a and the 4 is the b. So you're just going to do 1 over b minus a times the definite integral from a to b of your function dx. It's that simple. Now, for this part right here, you're just going to run your fundamental theorem. So I like to do that first. So I will calculate this. That's just going to be 1/3 times. And now I want to make sure I keep that 1/3 out and just kind of run this separately. So now when I do my antiderivative of x squared, of course I get 1/3 x cubed, and I'm running this from 1 to 4. So this is going to give me this 1/3 out front, not to be confused with this 1/3. Now, I'm going to plug in the 4 for x, so I'll have 1/3 times 4 to the 3rd minus 1/3 times 1 to the 3rd. Okay, I'll come up here. So this is going to equal 1/3 times, here we have 64/3 minus 1/3, which is going to be 1/3 times 63/3, which is 1/3 of 21, which is 7. And that's it. That's how simple. I told you this was an easy lesson, and it is. That's how you find the average value. So that's not going to be a problem. The problem is my why people who are like, okay, that's fine, Miss Callahan, I'll use this and I'll do this for you, but where the heck did that come from? And why is it finding the average y value? So here comes the derivation of the formula. Okay, so kind of take you through some fill in the blanks here. It says, to find the average of n numbers, so let's pretend you're back in middle school. The average of n numbers, what you would do is you would take the sum of the numbers divided by n, how many you had. This is how you used to do it back in the old days. Okay, well, let's switch it up now. The average value of a function, then, would be the sum of all the y values. So if the average value of a function is the average of all the y values, then you've got to add up all the y values and divide by the total number of x values used to generate those y values. Kind of goes in a circle there, but yeah, you're just going to add up all the y values and divide by how many x values are used to generate those y values. But here's the problem. There are infinitely many values to consider. So we'll deal with that on the next page. But I just want to remind you one last time here, the average value of a function equals a y value. Just remember, this 7 is just the average of all of the y values on the quadratic function x squared between 1 and 4. Okay, let's flip the page. Now on to how we derive this formula. So this next bullet is kind of weird. You'll see why I need to do this later when we get down here, but let's just read it. It says, consider what happens when we take a large sample of n numbers from regular subintervals of the interval a to b. Each subinterval is going to have a length of delta x equals b minus a over n. We've used this so many times throughout Chapter 5. But look what I'm having you do here. I want you to take this formula and solve it for 1 over n. So we're just going to use a little algebra. So if delta x is equal to b minus a over n, and we want to solve this equation for 1 over n, then what we can do is we can multiply both sides by 1 over b minus a. What will happen if we do that is these b minus a's will cancel, and I'll have 1 over n equals 1 over b minus a times delta x. Or I could write that as 1 over n equals delta x over b minus a. So just keep that in your back pocket for a minute. Okay, coming down. Last part. Okay, if we average, the average of the n sampled values is, okay, so if we're finding an average y value, wouldn't it make sense that we would take a y plus a y plus a y plus a y, we take this infinite number of y values and divide by n, how many y values we've considered. We know f of x is just another way of writing y. So this is me showing that the average of all the y values is add all the y values up and divide by how many x values we had to generate those y values. Okay, so let's go on a little journey here. If I rewrite this, I could rewrite this as this. This n on the bottom I could write as 1 over n times this sum, f of x sub 1 plus f of x sub 2 plus f of x sub 3 dot 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 plus f of x sub n. Okay, see the summation going on there? So now I have 1 over n times the sum from I equals 1 to n of f of x sub I. And we know this notation from Riemann. So I'm just shortening the summation up with my sigma notation. Okay? Next, I know that 1 over n from up top here is delta x over b minus a. So I'm going to rewrite this using that fact. Next, I am going to take the delta x that I have right here, and I'm going to multiply it back inside with the sigma, which is going to give me 1 over b minus a times the sum from I equals 1 to n of f of x sub I delta x. And finally, from our Riemann sums and shortening it up to the fundamental theorem of calculus, I know that when I let n approach infinity, I want an infinite number of y values added up and divided to find the average. I know that that becomes the definite integral. So my final answer here for average value, average of all the y values, is 1 over b minus a, definite integral from a to b of f of x dx. That's Riemann becoming the shortcut. And there you have it. That's where it comes from. Okay, so your homework tonight, right here on the next page, just finding average value using the formula for each problem. I could pick anything on here. Say we were doing number 9. Just remember, if you're doing something like number 9, just set it up. Average value of the function equals, and then go for it, 1 over b, which would be 0, minus a, which is negative 4, watch that double negative, times the definite integral from a to b of your function negative x squared minus 6x minus 3 dx. You know that's going to give you 1/4 times, and then you're going to anti-differentiate. So when you anti-differentiate this guy, you're going to get negative 1/3 x cubed minus 3x squared minus 3x from negative 4 to 0. I just want to keep that separate from the 1/4 out front. And then keep that 1/4. You're going to plug your 0 in. So you'll have negative 1/3 times 0 cubed minus 3 times 0 squared minus 3 times 0 minus negative 1/3 times negative 4 cubed minus 3 times negative 4 squared minus 3 times negative 4, which will give us 1/4 times. This whole guy is going to give us a 0 minus, and now we have to get in here. Here we're going to have a negative 64 times a negative 1/3 is a positive 64 thirds. We've got a positive 16 times 3 minus 48. And then a negative 3 times a negative 4 is a positive 12. Okay, so that's going to give us 1/4 times 0 minus. Let's get this guy in here. Let's see. Negative 48 plus 12 would be negative 36. So we have 64 thirds minus 36. And if I turn 36 into thirds, let's see, 36 times 3 is 18, 108. So I have 64 thirds minus 108 thirds, which is going to be 44, negative 44 thirds. Hope my math is right here, just doing this on the spot. So then I have 0 minus negative 44 thirds, which is a positive 44 thirds, times 1/4 should give me a grand total of 11 thirds. So I look back at number 9 on my answer key, number 9, and there it is, 11 thirds. So you can check all your work tonight with average value. Okay, good luck with this. Hope it makes sense, and we'll see you in class tomorrow.